This section introduces the single move that 2 centuries of causal thought compress into. Replace the observed contrast with the contrast that was never observed. Everything after that move is bookkeeping for the missing half. Hume could see only constant conjunction. Mill's canons still read cause off circumstance. Naaman's urns broke it open by naming the yield a plot would have given under a variety it never received. The chapter's real device is the double what if study, data simulated from a known causal graph. An estimator of the unobservable can only be graded against a truth you built yourself. The US and China mortality table carries the warning. An association can reverse under a third variable, and nothing in the numbers announces it. This part explains what conditioning does to a probability. Conditioning changes the population. Every number in the book is already conditional. 0.88% is the death rate, given residing in the US, given the year 2019. There is no unconditional baseline waiting to be refined, only a lattice of subpopulations connected by the law of total probability, which averages the finer strata back into the coarser one using the stratum sizes as weights. That averaging is the whole engine of the chapter, and its immediate consequence is the chapter's warning. Conditional independence and marginal independence imply each other in neither direction, because collapsing over H mixes in how H is itself distributed. Expectation then arrives as the same object in linear clothing. For a binary Y, the conditional expectation of Y given T equals the probability that Y equals 1 given T. A regression model is therefore a model of a conditional expectation, and the causal machinery of the later chapters is built entirely on re-weighted strata. This section explains why a causal effect can be defined for one person, but never measured in one person. A causal effect is a contrast between Y of 1 and Y of 0 inside a single person, and the consistency assumption, Y equals Y of t, hands you exactly one term of that contrast. The absence of the other term is structural. No instrument recovers it. Every recovery patient is therefore one of 4 causal types: doomed, responsive, harmed, or immune. The observed Y narrows that set to 2 permanently. The chapter's move is to abandon the individual contrast and purchase a population. 1. Randomization makes the potential outcomes independent of T, so the expectation of Y given T equals little t estimates the expectation of Y of little t. Everything the book does afterwards is a different price paid for that same purchase. This section explains why a treatment that works better in one stratum may only be doing so on the scale it was measured on, and where one comparison escapes that. Whether a treatment works better in one stratum is a property of the scale it was measured on. The risk difference, the risk ratio, the complementary risk ratio, written RR star, and the odds ratio can rank the same 2 strata against each other differently. Each one is just beta 3 on a different link: identity, log complement, and logit. The chapter's turn is that one such comparison escapes the scale. Superadditivity on the difference scale, together with monotonicity, places a lower bound on the fraction of individuals in whom the 2 causes synergize. That is type 2 of the 16 causal types, the type whose outcome fires only when both exposures land. Statistical interaction describes a model's parameterization. Causal interaction counts people. Recovery's dexamethasone modifies consistently across all 4 measures. The NCES data disagree across them, which is the ordinary case. This section explains the causal-directed acyclic graph, a factorization drawn as a picture. The joint distribution of x1 through xp equals the product over every j of the probability of xj given its parents. What the graph adds is that the absent arrows carry every claim. Encoding the assumptions in topology converts conditional independence from algebra into path blocking. D-separation decides by inspection what factorization shuffling takes pages to derive, and it yields independences that were never obvious in the factorization you started from. The chapter yield for the rest of the book is the backdoor theorem. The question, what must I adjust for, becomes the question, which backdoor paths stay open? With it, the associational notion of a confounder dies. W2 in figure 5.3 is associated with both A and Y, yet conditioning on it is worse than conditioning on nothing. A sufficient adjustment set need contain no true confounder at all. This section explains how confounding is diagnosed on a causal diagram and then removed by standardization. Confounding is the failure of a comparison to be a comparison. The treated and the untreated differ before treatment ever acts, so their outcome contrast mixes the effect you want with the sorting that produced the groups. Hernan and Robbins replaced the question of how to remove bias with the question of what the causal diagram licenses. A backdoor is any non-causal path from treatment to outcome that runs against an arrow into treatment, and blocking every one of them restores exchangeability inside strata of whatever you conditioned on. Standardization is then bookkeeping. Compute the outcome mean in each stratum where the comparison is legitimate, then reweight by the population's own covariate distribution. The chapter's function in the arc is to convert an identification condition into an estimator. This section explains how difference in differences buys adjustment when the confounder is never measured. A control group's pre to post drift is an estimate of the confounding itself. Chapter 6, adjusted by measuring a sufficient confounder and standardizing over it. Here, the confounder stays unmeasured, and the assumption moves to equal confounding outcome among the exposed minus the exposed, among the unexposed already at baseline. Written out the expected untreated outcome at follow-up among the exposed minus the expected untreated outcome at follow-up among the exposed minus the expected. Uncome among the exposed equals the expected baseline outcome among the exposed minus the expected baseline outcome. Subtract the unexposed change from the exposed change, and the ATT survives, as the NIRP bank margin example does in 3 lines of arithmetic. What the chapter is for in the arc: adjustment bought without a sufficient confounder, paid for with a scale-bound assumption, additive, multiplicative, or logit equi-confounding, of which at most one typically holds, and no data says which. This section explains the front door method, the chapter's second route, past confounding. Confounding. You cannot measure stops mattering when the entire causal pathway is observed. The move is factorization. Split the effect of A on Y into 2 pieces. A leads to S, and S leads to Y, choosing S so that each piece is I. U cannot reach S, so the A to S factor is clean. A is itself a sufficient confounder for the S to Y factor, so backdoor standardization closes it. The unmeasured U is routed around rather than adjusted for. No adjustment ever touches it. Its place in the book is the complement of Chapter 6. The backdoor method buys identification with measured confounders. The front door buys it with a fully mediating mechanism. Pearl proposed it in 1995. It is clever and nearly unused, with 1 published application, because the missing arrow from U to S is rarely defensible. This section explains how instrumental variables adjust for confounding without ever measuring the confounder. Every earlier adjustment method blocks a path you can see. The instrument works from the other side. a variable t whose only route to y runs through a, lets the unmeasured confounder u stay unmeasured. Identification comes by rescaling. You divide the intention to treat contrast by how much t actually moved, a. That one ratio is the chapter's entire content. The surprise sits in its interpretation. Under no defiers, it estimates the effect among compliers, the complier average causal effect, KIES. Under a structural nested mean model, the same arithmetic estimates the effect on the treated, ATT. Identical number, different populations, different assumptions, bought. And when t barely shifts a, the denominator approaches 0. The what if study's weak instrument shows the estimate detonating accordingly. This section explains what the propensity score does and why one number can replace many. The propensity score is a dimensional collapse. Rosenbaum and Rubin proved that if the whole confounder vector h suffices for exchangeability, then the single number e of h, defined as the probability that treatment equals one given h, suffices too. Adjustment stops being a modeling problem in however many dimensions h has and becomes a one-dimensional one in however many dimensions h has and becomes a one-dimensional one. Everything in the chapter, regression on E, stratification by quartiles, matching within a caliper, is one primitive applied 4 ways. Balance the scalar and the vector balances itself. The cost is that correctness now rests entirely on the exposure model being right, and the check that replaces it is visual, overlapping densities of E across treatment arms. Non-overlap is positivity, failing where you can finally see it. This section explains why a covariate that is independent of treatment can be added at no cost to the answer, and what that addition buys. Independence from treatment is what makes a covariate free to adjust for. It cannot shift the estimate, so everything it explains in y leaves the residual and never returns. Beta 1 is identical in the expectation of y given t and v, and in the expectation of y given t alone. The second model merely carries beta 2 times the quantity minus the expected phi given t alone. Bias and variance are therefore governed by disjoint sets of variables. That is the chapter's pivot in the book's arc. Everything prior bought unbiasedness, this buys precision at almost no cost. A useless V costs a sliver of finite sample variance. A good one buys arbitrarily much. The consequence is a standing policy rather than a search. Fix V before randomization, since picking whichever gives the smaller standard error afterward is a multiple comparisons test, wearing a disguise. This section explains why mediation asks for something no experiment can hand you. Randomizing. A buys the effect of A. It cannot buy the effect along a path. The object mediation wants, written y of A with m of a star, assigns treatment one way and the mediator to the value it would have taken under the other, so no single world realizes it. That splice is the chapter. Controlled effects stay inside one world by fixing m equal to little m and cost 2 confounding assumptions. Natural effects cross worlds and cost 4, the fourth being that no mediator outcome confounder is itself affected by treatment. Both partitions add back to the total effect. The residual difficulty is identical in every trial. A can be randomized, M practically never, so H2 is never bought. This section explains why one variable holding 2 roles at once breaks every adjustment method the book has built. H2 confounds A2, yet it mediates A1. Condition on it and you erase the effect you came for. Leave it and A2 stays confounded. The backdoor toolkit has no legal move. The escape is to stop conditioning and model potential outcomes directly. One root rewaits so that each stage's treatment is severed from the history that predicted it, and that is the MSM. The other peels time slices backwards, subtracting the later stage's effect before estimating the earlier one, and that is the SNMM. That backward peel is dynamic programming, and it converts the estimate into a regime, a rule mapping what you observe at time 2 into what you do.